This is a preliminary film report on Project Sedan, a 100-kiloton nuclear cratering detonation recently executed as part of the Atomic Energy Commission's Plowshare program. Plowshare envisages many uses for nuclear explosives, including applications in nuclear excavation, mining, production of useful isotopes, and power. Nuclear excavation is, however, the most straightforward application and the nearest to practical usage. The chairman of the Atomic Energy Commission has recently established within the Plowshare program a research goal to determine the feasibility of nuclear excavation within approximately the next 5 years. Project Sedan was the first step in implementation of this program. The basic objective of Sedan was to determine the cratering effects of a deeply buried, high-yield nuclear explosion. Previous experience with 1 kiloton and smaller explosives has shown that as a nuclear explosion is buried deeper and deeper, crater size steadily increases until a depth of burst is reached for which crater dimensions are maximum. Below this depth, crater size decreases. Also, as the explosion is buried deeper and deeper, the fraction of the radioactivity released to the atmosphere becomes less and less. Thus, it is possible to choose a depth of burst that will give almost maximum crater size with the release of only a few percent of the radioactivity. Using these concepts, the depth of burst chosen for Sedan was 635 feet. The predicted crater diameter ranged from 1,200 to 1,500 feet, and the depth from 180 to 315 feet. The release of radioactivity was expected to be less than 4%. The explosive used for Sedan was a 100-kiloton thermonuclear device in which less than 30% of the total energy came from fission. Since only a few percent of this fission fraction escaped to the atmosphere, less than 2 kilotons of radioactivity was released by Sedan. The site of Sedan was the Atomic Energy Commission's Nevada test site, located in southern Nevada, 70 miles northwest of Las Vegas. The specific location chosen for Sedan was at the north end of Yucca Valley, near the site of 2 earlier nuclear cratering detonations and much high explosive cratering work. Sedan was detonated at 10 a.m., July 6, 1962. This is a view taken from the top of a 1,500-foot tower located 6 miles from ground zero. These sequences are being shown at about 1/3 normal speed. The base surge, seen forming here, continued to grow until it covered an area about 5 miles in diameter. The main cloud rose to a height of 12,000 feet above the desert floor. This close-up view was taken from a ground station 3 miles from ground zero. The dome rose to a height of 290 feet before it vented at 3 seconds. This long view gives a better picture of the mass of material moved by the explosion and the early stages of cloud formation. A very large fraction of the radioactivity that escaped from Sedan was mixed with the fallback in the crater area. Thus, the cloud carried only a small fraction of the radioactivity. The area covered by the base surge is clearly discernible in this aerial view by the pattern of light-colored dust. The crater is about 1,200 feet in diameter and 320 feet deep. The lip ranges in height from 20 to 100 feet. The predictions and the results compare favorably. The fallout pattern from Sedan extended almost due north from the crater area. Shown here are the 5/10 Renchten and 3.9 Renchten isodose lines. These correspond to the total dose a person would receive assuming continuous residence. The highest dose received by any off-site resident was 2/10 Renchten. These isodose lines represent the dose one would receive assuming entry into the area 1 week after the shot and continuous residence thereafter. Research is being done on nuclear explosives with so little radioactivity that excavation projects will be possible with no off-site radiation problem. Large-scale excavation projects, such as harbors and canals, require the use of explosives in the range from 100 kiloton to over a megaton. Sedan has been a major step forward in the nuclear excavation program by extending our cratering experience into this high-yield range.